Hi everyone, what's up? All good? Great. Today we will be solving the question intersection of two arrays. So let's see what is this question. Given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must be unique and you may return the result in any order. So we are given with two arrays, nums1 and nums2, and we just need to return their intersection. Okay. So each element in the result must be unique and may return the result in any order. Okay. So let's see what is this question saying. So here you can see that we are given with two arrays, nums1 and nums2. So what are the intersection points? Let's see. Their intersection points are 2. But as we are given that the element in the result must be unique. So you don't need to return the two times. You just return the two only one time in the result. Okay. So we just need to find the intersection of these two arrays and the element in the result should be unique. Okay. So here you can see what we need to do. We need to take each element and then search for that element whether it exists in nums2 or not. So first of all, we will start iterating nums1 and then search in nums2 whether that element exists in nums2 or not. Okay, so what will be its time complexity? It is completely brute force approach. As you can see that we are iterating nums1 and then iterating nums2 for finding that element. So let's say its length is n and its length is m. So then its complexity will become big O of n into m. Okay, but it's not good. So let's see how we can optimize it more. Okay, so what we can see is we need to search that element in another array, right? Okay, so here you can get the idea. Whenever we need to search that element in some array, then what we can do? We can apply the binary search approach. Okay, so but here we are not going with the sorted arrays. So let's say first of all we will sort this nums2 array and then we will find that element in nums2 array with the help of binary search. Then what will be its complexity become? So first of all, we will need to sort this nums2 array, then its complexity will be m of log m plus, then we will be iterating this nums1 array and then finding that element in nums2 with the help of binary search. So it will become n of log m. So this will be the complexity for binary search approach. Okay. Yeah, okay, cool. But it is also not linear time complexity. So let's see how we can do it more in optimized way. And here the space complexity will be big of 1 as we are not using any extra space. Okay. So the one more way for doing this question can be, let's see, we have two arrays. Okay. 1, 2, 2, 1 and 2, 2, right? Okay. So let's say if we can simultaneously check on both these arrays, whether these two elements are equal, then we will simply push them in our result. So whenever we are checking two arrays simultaneously, then this approach becomes two-pointer approach. Okay. So let's say we can iterate in these two arrays simultaneously. But what's the catch here? Here we are not given with this sorted array. So first of all, we will need to sort both these arrays, which will take the complexity of big O of n log n plus big O of m log m. Okay. Yeah. Now we will simultaneously iterate these two arrays. And if these two elements are equal, then we will simply push them in our result. And if not, then we will simply increase the pointer which is pointing to the lower element. Now, if they are equal, yeah, they are equal, then we will simply push them in our result and increment both the pointers. Okay. So now what will be the complexity? Its complexity will be now we go of n comma n because whenever any pointer goes out of bound, then we will break our loop. So this will be the complexity for two-pointer approach. And its space complexity will be big O of 1 as we are not using any extra space. So as you can see that binary search approach is better than this approach because here we need to sort both these arrays and then an extra complexity of minimum of n comma n to iterate these arrays. And here binary search approach is better because we are not given with these sorted arrays. Okay, now let's try to convert it in linear time complexity. Okay, so now let's see again. Here we are given with two arrays, nums 1, 1, 2, 2, 1, nums 2, 2, 2. Now what we need to do? We need to search if this element exists in this or not. Okay. So if we just need to find whether this element exists in this or not, so what we can do? Either we can use hash map or we can use hash set, right? We can simply store the elements of nums2 in this hash set and then find whether this element exists in this or not. If yes, then we will simply push that element in our result. If not, then we will simply check for the next element. So what will be the time complexity of this approach? First of all, let's say its length is n, its length is n. It will take m O big O of m for storing these elements in our hash set. And again, then big O of n for iterating this array for checking whether this element exists in this or not. And its space complexity will also be big O of, let's say, minimum of n comma n because we will store the elements which have lesser, we will store the array which have lesser number of elements in our hash set. So this will be the hash set approach for this question in which we have converted it to a linear time complexity. Okay, so now let's try how to code this approach. So what we are doing here, first of all, we are creating an HashSet for storing the elements of nums2, let's say nums1 dot p, sorry, nums2 dot n. If you want to apply that check for this, you can also, but here I'm skipping that thing. Okay, so now what we need to do? We need to iterate the nums1 and then we need, yeah, one more thing. We need to create a one more set. Why? Because here we are given that we need to find the unique integers. We need to store the unique integers in our result. So we need to create one more set here for storing unique integers. So now here we will apply a condition that if that element exists in this set, then we will simply push that element in our set. Okay. Now after this, we will create our vector result and iterate in our set and simply push all the elements of the set in our result, and at the end we will return our result. Now let's try run this approach. Hmm, yeah, just spelling mistake. Okay, let's try run this again. What's the issue here? Oh, sorry, just doing silly mistakes. Nums one dot size. Yeah, it's working fine. Let's try submitting this. Yeah, it's working fine. So here you can see that we are using two set because we need to store the unique integers. So here the space complexity will become minimum of n comma m into 2. Okay. Yeah. So this was all for this question. I hope you get it. It was a very easy question. If you still have any doubts, you can share the post in the comment section. I will try to answer them. Till then, bye bye guys. See you soon in the next video.